I talked about the Czech free network. You can see here, lower right part, you can see the map of the Czech Republic. And that's roughly this area here. And around Prague, everything is totally covered. So this is the Prague area. And Freifunk is a very well-known name, and they have many cities in Germany. And as a brief update from the Freifunk network, for the first time we cross-connected different Freifunk networks with the OLSR routing, just in order to prove that it scales to thousands of nodes in practice. We did that recently, it does. So this is the Leipzig network, just the topology. And yeah, if you want, I can talk about the protocols themselves. I wasn't sure if that's interesting for... No? Yes? No? Okay, I'll skip that, in case you have questions. Okay, I think I should hurry up now. So, lessons that I want to share with you is, I think making it a community-based effort is actually the most democratizing thing you can do, because people start to build their own infrastructure, and therefore they start to care about it. They start to protect it usually, and they learn, they empower themselves. And actually, you can do it, even without lots of cash. We started with virtually zero, and then, you know, a couple of us put in a little bit of money into it. We bought the remains of a dying ISP, took the parts, the switches which we needed, sold the rest, and just worked ourselves up. And yeah, internet access for free is, you know, is very tempting. You can really get people involved in that initially, and then eventually they will actually understand that there is something more behind it, not just internet access for free and just consuming it, but actually creating it on your own. The lesson is also you can really have good connectivity with very little bandwidth, average use. Of course, you need to be able to sustain the spikes. When somebody really downloads something, you need to be able to give them the spikes. Yeah? And that's where Wi-Fi is weak, actually. Yeah? We need better layer 2 technology. But you know, still 20 to 30 megabits is doable for us. People get effectively 20 to 30 megabits netto over good links. If they construct bad links, it can be as low as 15 kilobytes per second. Still enough to get email, but slowly. Okay, so for that we pay really little. We're at the right spot next to the Vienna Internet Exchange. All the ISPs are there. It's cheap for us to buy bandwidth. 200 euros per month. That's sustainable. And we need some kind of backbone, exactly, because of the mesh, the multi-hop classical ideas of the mesh with 8, 9, 10 hops on the same channel. That doesn't work. We need to have, so the backbone is really multi-channel. It's totally multi-channel. So I think it's called Generation 3 mesh networks in some papers. We need more of that. We need to have more frequency. We need to have better Wi-Fi equipment. We need to go probably into the direction of MIMO. I can see that really coming.
What's MIMO?
Multiple in, multiple out. It's phased array / beamforming. So the antenna will just be able to listen. It's like you have 5 years. So your 5 years can cancel out the noise from back here and listen to back here very carefully, or you know, you can steer the beam if you want to. Yeah, it's a phased array basically.
What flavor of Wi-Fi are you using?
802.11a BG, all that we can get. We need as much frequency as possible. That's also something that I want to come to later. We just really, opening up the spectrum is essential. Okay, and essential also is interference management. So we do use a lot of directional antennas just in order to keep out the interference. Yeah. And funny enough, we are supported by ISPs because we're still at that range where we're so small compared to regular ISPs, that actually they see us as a invention lab. We're not really a threat to them, and they're supporting us with know-how, with helping us splicing fiber, things like that, small things. Yeah. So often this happens, when techies talk with techies, and there's a beering involved, so there's a six-pack being handed over.
Can you say a little more about? I understand that you're too small to bother them, but do they see some advantage other than the
Yes, actually, those ISPs who help us do get regular updates of what we're doing and what we're inventing, and what, for example, the oldest art development is doing right now. So they get informed. That's pretty valuable for them.
There's another side to this. They're bringing in customers these people never had before.
Yeah.
They walked away from it.
Yeah, maybe. Yeah.
They're bringing in, they're bringing in users, people who
Users.
consume, so to speak,
Yeah.
consume bandwidth,
New customers
who end up paying.
who end up consuming bandwidth.
Bandwidth, which we buy.
Which they buy.
Okay.
Yeah. And also the city of Vienna is helping us, and some a foundation of the Internet Private Foundation of Austria helped us also. So thanks to them. So I just got this picture before this talk. This is the first own fiber, really own fiber connection. The other one was like shared, but this is we're starting to dig. It's really exciting for me. And the other thing where I'm really focusing on is the development of the mesh protocol, OLSR, because it's so essential. It's really the glue. And I think we're pretty done with scalability. You can go higher to millions, but I think we're now in the thousands range, which is good already. I want to look at different aspects of it now. I want to have routing packets signed, because in Wi-Fi you can introduce any packet into the air at any moment. So if you have a routing packet from OLSR saying, I know where everybody else in the world is, route to me, then you can be very easily a black hole, or you can intercept traffic. So it's in that aspect, we're still very, very vulnerable. So we have to really work on something that, interestingly enough, the military is also interested in, signed routing. So we will only accept routing packets by nodes that we know. This is going to be an interesting aspect, what it means, like, for the whole structure of the network. Who decides who's welcome or not? That's a good question. But we will need something like that. Otherwise, it's just one single idiot can destroy the routing. So I have no better solution. Maybe you have. Then there is an algorithm from the ISIS protocol, which will make it converge really rapidly in case the routing tables are out of sync. It's called CSN algorithm. And eventually I want to end up, this is probably in a couple of years, with multipath routing. So the packets get sent out in parallel over multiple paths. So it can balance out like water flowing through different pipes. It's a dream. There are dissertations about it, but it's not easy to implement. Yeah, quicker conversions, I said that before. And I'm starting with, I think I can say that, with Sasha, Meinrad, and a few other people in the EU. I'm starting something which will push for more open frequencies. And I'm hoping maybe one of you here in this room has some ideas or some connections to important people who have been already doing that in the EU. Maybe we can link up with more work which is done in the States for opening up the spectrum. I think this is essential. This will be the basis for the future. And yeah, thanks. And I want to say one more thing. I forgot to add that to the slides. Why do I think that spectrum is so important? Because in the future we're going to see more developments in the area of nanotech radios. So I don't know if everybody of you in the room saw that MIT Tech Breakthrough, whatever, 2008, I think it was 2008 report. A group in Berkeley by Professor Zettel managed to make radio receivers, antennas, with nanotubes, with carbon nanotubes. So these are 200 nanometers long. And once you have those, they were able to receive a normal FM radio and amplify it. And once you have those in parallel, you have that phased array again. You can have really the wireless switch, and that's what we need. We need to be able to listen only in that direction and disregard any interference from a different direction. And then once we're there with a wireless switch, we can really scale up Wi-Fi very highly. So, yeah, thanks. Okay, let me see. I think it's here. This one?